6B. This one is kites, okay? Did I just turn that crooked a little bit? So trapezoids and kites are both a little different. They have a lot of angles that you got to figure out what matches up with what. But first, the definition, okay? A kite is a quadrilateral, four-sided figure with two pairs of consecutive sides that are what? Congruent. So two pairs of consecutive sides that are congruent. And no, oh, I added a word in there. That shouldn't say congruent. Oh, no. That's right. Sorry, I was thinking the next part. And know what sides that are congruent. So consecutive sides that are congruent, so these two and those two are congruent. No, any guesses? What's that other blank? Right, you can't have any opposite sides congruent, okay? So consecutives, ones that are next to each other are congruent. Ones across from each other cannot be, okay?
So does that mean that wouldn't they all be congruent then? Because there's, like, wouldn't the one on the top left be congruent with the one on the bottom left too? So there's just consecutive?
Nope, because it's two pairs of consecutive sides, right? So a pair here, 1, 2, and a pair here, 1, 2. It can't be that both pairs have congruence as well. Yeah. Okay, so that would be a kite, or if you flipped it on its side, this would be a kite. Okay, so it doesn't matter vertical, horizontal, how you view it. It just has to be two are congruent that are next to each other, and the other two are congruent, but they're not all four going to be congruent, okay? So that's a kite. And then the next thing just says what we know about a kite. This says the diagonals of a kite are perpendicular. What other figure has perpendicular diagonals? Not a rectangle, a rhombus, right? So rhombus, which is also a square, and a kite all have perpendicular diagonals. Didn't make my blank big enough for me. So this is 90 degrees, but that means all of these are 90 degrees. Okay, and a kite is a little, it gets a little hairy with what is what here. Your diagonal, okay, let's just bear with me for a second. Let's say these are the congruent parts, right? The diagonal that cuts the congruent parts is also a bisector. So in other words, you have, we're going to zoom way in on this just so I don't make it terribly ugly. This angle right here is the same as that angle, okay? And this bottom one is also a bisector. This one is the same as that one. Notice they are not the same as each other, okay? So it is bisecting, but opposites aren't congruent like a rhombus was. So the two up top are congruent, the two on bottom are congruent. The other diagonal doesn't bisect, but you still have some congruence there. So the other diagonal, you end up with these two the same, and the ones right below that are the same, but they are not all four the same as each other, okay? So this one down here and this one here are the same, okay? And all of that is because of different triangle congruence. Like if you look at these two bottom triangles, you have HL there, okay? So that's how we know those angles are congruent, is because you have congruent triangles. With that, if we took out the diagonals, so let's say we were looking at a kite without the diagonals drawn in, do you think any of those angles are congruent?
Yeah.
Which ones?
The one on the left and the one on the right.
Right, so in this setup, now these are congruent, okay? The other two are not, but the two that have the different side lengths that form it, are congruent. So with the diagonals drawn in, it's one setup. Without the diagonals drawn in, these are the only ones that are going to be congruent. Okay? Any questions on any of that? Yeah.
Would the horizontal line also on the diagonals, would that be cut in half?
Yes. Yeah. This would be right. So same thing by HL. You could say that these are the same length. That's what you're asking, right? Yeah. Good observation. Okay. Any other questions on that? All right. Then we're gonna do a couple problems. Okay, if I tell you that these are kites, so these are the same and these are the same, okay? Knowing what we know about kites, what are the measures of the numbered angles here? So what is angle 1 in that picture? 90, because diagonals are perpendicular. Okay, so all of these are 90. Okay, so we would say angle 1 is 90 degrees. So how do we find angle 2? Yeah, Jared.
180
And then what? Okay, you can't divide it by 2, but you're getting there. Yeah, Daniel.
90 plus 40 and 180 minus that equals.
Right, so if angle 2 is here, it's also here, right? That gets bisected. So now if you just look at this triangle, a triangle always has to add up to 180. So you can say 90 plus 40 plus the measure of angle 2 is 180. Okay, so if I take that away, that's 130. So take away 130 here. We get the measure of angle 2 would be 50 degrees. So this angle here is 50. Okay. Questions on that? So look for triangles. You're going to use triangles a lot in kites, especially, when the diagonals are drawn in, you're going to use them all the time. Okay?
What I was gonna say.
Yeah.
Could you also do 40 plus 40 and then 180 minus that divided by 2?
Yeah, you could look at it as this triangle because we know it's isosceles, right? So then this base angle over here is also 40, and then that vertex angle is being bisected, so you could cut that in half, yeah. All right, let's look at the next one here. What is the measure of angle 1, angle 2, and angle 3? What's the measure of angle 1, Matthew? Angle 1 is going to be 90. Ladies, with me. So angle 1 is 90. Okay. I would say the easiest next angle to find would be angle 3. What's angle 3? 36. So these two are going to be the same. If it helps you to see your markings here. The kite's laying on its side, right? So 3 would be 36 because that gets bisected. Okay. So then if this is 36, what is angle 2? 54. You're going to subtract from 180. So 36 plus 90 plus the measure of angle 2 would equal 180. So if we subtract that, that's 126. Then the measure of angle 2 comes out to 54 degrees. And that would give you all three of your angles. Any questions on that? Okay. The only other thing that I have for you then is just a picture, and this came straight out of your book. But I feel like it does a good job of helping you to understand kind of the relationship between all of these. So everything we've talked about is a quadrilateral. What's a quadrilateral? Four-sided figure, okay? So with quadrilaterals, you branch off one way, there's no parallel sides. Branch off another way, there's one pair of parallel sides. Branch off the other way, there's two pairs of parallel sides, okay? The way you can think of this is everything at the bottom is everything above it. So if I go to a square, for instance, a square is a rectangle, a rhombus, a parallelogram, and a quadrilateral, right? If I go to a rhombus, it is a parallelogram and it is a quadrilateral. If I go to a trapezoid, it is a quadrilateral. If I go to an isosceles trapezoid, it is a trapezoid and a quadrilateral. So everything at the bottom is everything above it. Everything at the top is not necessarily everything below it. Does that make sense? So a quadrilateral is not necessarily a square, but a square is always a quadrilateral, okay? So you're kind of working from the bottom up with that. Does that make sense? Questions? And then this just kind of gives you the details of it: 4 right angles, 4 congruent sides, 1 pair of parallel, 2 pair of parallel, no parallel, and then all the markings, like your parallel lines. Everything here is also true of the things below it, right? So a rectangle has those parallel sides. Same for a rhombus, same for a square. They just don't draw them all in because everything there is going to flow down, okay? It is coming down good right now. Okay, any questions on that?